Okay, students. Good morning. So today, as I said, we are going to do the passes of the ideal gas. Okay. So everyone can hear me, right?
Yes.
I can see the document. This is the passia of ideal gas. Passia is all in the times. So just a recap. What you learned about ideal gas. First, you learn PV over T is constant. Then what do you learn? PV equals to
And
RT. Then you learn PV equals to GT. Then from the theoretical scientists, we found that PV equals to 1/3 and MC squared, which is the biggest, the most important development, which we tested a lot. Okay, and comparing the first two, the last two equations, kinetic energy has been found. This, the one here is the fifth one. Okay, and between we talk about Brownian motion. Brownian motion, you should know what is the observation, what is the conclusion. What is the observation? Observation is the dust particle
moves in a jerky manner.
jerky manner. That's the observation. What is the conclusion? The the dust particle has been randomly colliding with the tiny little air particle. Therefore, air particle moves randomly. Conclusion. Okay, so let's do this question. The first question, recall back everything. Or before that, what is the theoretic kinetic of gas? 3 assumptions at least. Anyone? The first assumption is the
intermolecular force is negligible.
The intermolecular force is neglected. Intermolecular force is neglected. What else neglected?
The volume.
The volume of molecule. The volume of molecule is far smaller than the gas volume. And third, collisions are elastic. Okay, the collisions are elastic. So then, anything else? Fourth, the gas consists of small little particles called molecules. Molecules. So you need to know at least 3. Okay, so let's go to the question. Question 3. Okay, the kinetic energy of the gases leads to this equation. Explain the significance of this quantity. What is this? This quantity stands for? This is the mean kinetic energy. Mean kinetic energy. You must use the word mean. Mean kinetic energy. Okay, of the particle, can say molecule, can say atom. Mean kinetic energy. The keyword is mean kinetic energy of the molecule. Okay, or atom. The next, use the equation to suggest what is meant by absolute zero of temperature. What is absolute zero of temperature? Anyone? Okay, sorry. Sorry. Okay, Mazhar here. Mazhar? Mazhar? Okay, Mazhar. So what do you think the answer for this? Use the equation to suggest what is meant by absolute zero of temperature. What do you mean by absolute zero? Absolute zero temperature. Anyone? Mazhar? So absolute zero temperature is your -273.15 Kelvin. Okay. What do you understand by this temperature? It's the temperature where what becomes zero? It's a temperature where, yeah.
That's Celsius.
Again, mother, can't hear you.
Negative 273.15 is Celsius.
Sorry, yeah, degrees Celsius. Okay, degrees Celsius. Yeah, what happened? What becomes zero? Anyone? So it's the temperature where the kinetic energy of what? Kinetic energy of the particles. Kinetic energy of the particles becomes zero. Zero. So absolute zero. Okay. Okay. So next, two insulated gas A and B, two cylinder connected in a tube, negligible volume, as shown in the figure 3.1. Okay, the question is, each cylinder has an internal volume of this much. The tap is closed and cylinder A contains 1.2 mole of an ideal gas. The temperature of this. Cylinder B contains the same ideal gas at this pressure, 1.2, same pressure. Well, same pressure. Each cylinder has an internal volume of this. Initial tap is closed. Cylinder A contains 1.2 of that temperature. B got ideal gas at a pressure of 1.2 times 10⁵ Pascal and temperature 37. Or temperature same. Pressure might be different. We calculate the amount in mole of the gas in cylinder B. How do you do this? 1 minute for you. So calculate the amount of mole, the amount of mole contained in the cylinder B. So anybody, what formula do you think should be used? What do you know about cylinder B? Cylinder B contains this much of pressure. This is the temperature. You know pressure, you know temperature. You know pressure, you know temperature, you know volume. They're asking how many mole. So what formula? PV equals to nRT to be used. PV equals to nRT to be used. P, you know, P is 1.2 times 10⁵. P is 2 times 10⁻². And we are looking for R 8.31, get it from the front page. And the temperature, 37 degrees Celsius, is a trap plus with 273.15. So you get the number of mole. Okay, so just PV equals to nRT. The temperature, make sure you change to degrees Celsius. Okay. How many mole you got? So PV equals to nRT. So this is the step you have to use. Okay, you already know the number of mole. Assume that you know. Okay, go down. The tap is open. Some gas flows from cylinder A to cylinder B. Using the fact that, yeah,
0.991.
the mole on top, 0.911. Okay, next. The tap is open and some gas flows from cylinder A to cylinder B. Using the fact that the total amount of gas is constant, determine the final pressure of the gas in cylinders. Let's scroll up. So now the cylinders has been opened. So like here, look at the image. The tap has been opened, so the gas both need to going to mix. But they found that gas from A goes to the gas of B, It means gas A as high pressure, high pressure moving from A to B, and they mixed up. Then finally, new pressure was attained. So they're asking, what is the new pressure? 1 minute for you. How do you go about?
Is it also PV equals to nRT?
Yes, very good.
But
So
just
should we,
combine both of the values of the volume and with the same temperature, since both have the same temperature.
okay, temperature you're going to be how much? Temperature same lah, same, never change, because both are same temperature. So it's 37 plus 273.15. R we know is 8.31. And what do you put? Volume, what do you put?
Combine both.
Volume is combine both, yeah. So how much is the volume? One cylinder 2 times 10 power negative 2. So both cylinder together times 2 lah. So here will be what? 4 times 10 power of negative 2. Times 2. 2, both are same volume. How do you get the number of mole? This is the number of mole of B. So what do you have to do first? Need to find, number of mole of
A.
Find the n of A. You need to find the n of A. How do you find n of A? So again,
Isn't it given?
It's given. Oh yeah, it's given. A is given 1.2 mole. So what is the n you put here? The 1.2 plus with the one you got above lah. 1, and you get your pressure in Pascal. Okay, the others. So PV equals nRT to be used. Volume, you add both of them because both volume mixed, and number of mole, both n need to be added. Temperature remain the same because both cylinder has the same temperature. So you find a P. Okay. Has anyone got the answer? Okay, the others, please give a try. Okay.
So can I see the n value above?
N value above is 0.911. All of you got 0.911. Okay.
Um, 136 kilopascal. Oh, it's Pascal. 136000.
Okay, important is the flow. PV equals to nRT to be used. The volume need to be added. The N need to be added. Okay. Okay, next. Okay, guys, come on. 1 minute for you. Read the question. Tell me how do you go about for the A. This is gravitation with ideal gas. Okay, so they ask you to prove the object is projected vertically upwards. Planet fast enough speed, it can escape from the planet gravitational field. It means the object can arrive at infinity where it has a zero kinetic energy. The speed of that is just enough for the escape speed. Escape speed. So how do you find escape speed? What equals to what? This is gravity. Escape speed. You want something to escape from the Earth to infinity. So what type of energy must be equals to what type of energy?
Kinetic energy equals to potential.
Potential energy. It's normally put U. Okay. So yeah, so half mv squared should be equals to, what is the potential energy formula? G mm over R. R capital R. So from here, you'll get that formula. V squared equals to 2gm over R. Okay, your gravitation knowledge. Okay, next. And show that the g is the acceleration of free fall at the planet's surface. How do you got this? With this gravity with ideal gas, towards the end will be ideal gas. How this can be turned to become like this? The Rg, right? So it's it. The gravity is what?
G.
What is the gravity? Gm over R squared. So the Gm is actually Gr squared. The gravity at the surface times the radius of it. So from the above equation, V squared equals to 2 Gm, we can replace with Gr squared over R, we get 2Rg lang. That's the working. The gravity is Gm over R squared. Okay, so let's move on. Okay, so now this is ideal gas. The mean kinetic energy of an atom of ideal gas is given by 3 over 2 kT. Where K is the Boltzmann constant, T is the thermodynamic temperature. Estimate the temperature of the Earth's surface such that the helium atom of 6.6 times 10⁻27 kg could escape to infinity. Estimate the temperature at the Earth's surface such that the helium can escape to infinity. Yeah, the kinetic energy is that. You may assume that the helium gas behave as an ideal gas, that radius of Earth is that. What temperature required? So it's a connection of above, right?
Yes.
How do you use that? Sorry. What is the escape speed? Escape speed is V squared equals to 2Rg. V squared equals to 2Rg. V squared equals to 2Rg.
Use half mv squared.
Yes. So they want what? They want estimate the temperature of the earth. They want temperature. So half mv squared, the kinetic energy of the particle must be equals to 3/2 kT. Then what else?
Move 2, 3, and k.
23 mk.
Was one of the. Wait.
So m is there. The v is replaced with what? 2Rg, right?
G, yes.
So you find the temperature. M, do you know? M is what? M is 6.6 times 10 power negative 27 mass of the gas, the helium gas. R is what? R is the radius of the Earth. G is what? 9.81. K is what? K Boltzmann constant. And temperature. We are looking for the temperature. The answer you get here, what unit will be?
Temperature.
What unit will be? Kelvin. Will be Kelvin. SI unit. Okay, so someone please calculate. Half mv squared of the kinetic energy must be equals to the 3/2 kT. Okay. Has anyone got the answer? Yes, so some of you already got it right. What is the answer you got? So half cancel. Squared G squared M over 3K, right? Okay, how many Kelvin?
So
The others come up.
V square need to square one more time.
Yeah.
Because
V
V
squared.
square equals to 2Rg, and then isn't it 1/2 and 2Rg only?
Oh yeah. Sorry, why? No need. It's 2Rg. Okay, made a mistake. 2Rg. Yeah. So 2Rg M over 3K. Okay, thanks. This was the answer you got.
Is this true? I don't know if I made a mistake. I don't know if I made a mistake or not.
Okay.
It's like
So
0.0226 Kelvin.
quite small.
Is it? I'm not sure if that's correct.
Okay. Okay, this, yeah. Number 2, Number 2. So 2 times 10 power of 4 Kelvin.
It's larger.
Yeah. So you got the larger one, So half m squared 3 over 2 kt, v squared is 3 over 2 kt. Yeah, so this all Mark's substitution, final answer.
Okay, now I get it.
Okay, go up. So that's the question. So what is the conclusion you can make with this temperature? It's a huge temperature. Means what? What you can make at a conclusion. So the particle unable to escape from the earth, so create the atmosphere. The atmosphere is formed. All the particles, difficult for them to escape from the earth because the temperature required for them to escape is very high. Okay. So yeah.
If the gravitational acceleration, gravitational potential is not given, should we just assume it to be 9.81?
Yeah, because in the front page of your question paper, they put gravity as 9.81.
Okay.
The gravity at the surface. So you take it as 9.81. Okay. Okay. So next. Okay, recall back all your formulas you learned. Okay, 1 minute for you. Look at this question, 3A. Try to figure out what formula to be used. Okay, what formula to be used? Anyone have an idea?
PV over T.
Yeah, P1 B1 over T1 equals to P2 V2 over T2 to be used. Two sets of. This is one set, then the other one set. Okay. Okay, so you substitute. The pressure P1 is 1.1 times 10 power of 5. V1 is 540. Do you need to change the volume unit, centimeter cube to meter cube? Not necessary. You can leave it as centimeter cube because identical formula. Only temperature have to be in Kelvin. So down here Kelvin is 2727 plus 273.15. So P2 is how much? P2 is 6.5 times 10 power of 6. Volume 30 again, and find the T2. Find the T2. So volume, pressure, you can use any unit you like. But temperature have to be in Kelvin. So final answer will be in Kelvin. Okay. So those who figure out this is the equation to be used, good. So I think you're on correct track. Those who couldn't figure out this equation, you must do more questions. Okay. Whenever you have two sets, I think this is the formula to be used. If you only got one set and number of mole is given, PV equals to nRT or nKT. Okay. Okay, so I hope you can get the answer for this Kelvin. Okay, important is the idea. Yeah, well, let's move on. Move on. Okay, state and explain the first law of thermodynamics. You haven't learned this yet. This is going to be the next topic, because next topic also is about thermal energy. Okay, so we skip this first law, these two. These two will be the next topic. Okay, next. Explain the meaning of the symbol of C squared. What is that meaning? Anyone? It's the mean square speed. It's a mean square speed of a particle. It's a mean square speed. Mean, must say mean square speed of a particle in a gas. Okay, in a gas, an ideal gas. Okay. So next, B. Okay. Give you 1 minute. Get the working. Anyone got the answer? The ideal gas has a density given. Pressure is this much, and the temperature is given. Determine the root mean square speed of the gas at 300 Kelvin. Root mean square speed at 300 Kelvin. So, what's the formula comes to mind? Determine the root mean square. So we can say the kinetic energy of mc squared equals to what? 3/2 kT. Can we use this? Do you have enough information? You find the mean square speed. Do you know the mass of the particle? Temperature, you know, right? Temperature, you know. Temperature, you know. But mass, if you know the mass, you can find the mean square speed. Mass, do you know? The ideal gas has a density of this. Mass, you don't know. So you can't use this. Any other formula? So P equals to rho C squared, right? PV equals to 1/3 NMC squared. So you have to show that lah. You have to show that. PV equals to 1/3 NMC squared. So then P is 1/3 NM over V C squared. So this becomes density, right? The pressure is 1/3 rho C squared. Okay. Then from here, yes. So you know pressure, you know density, you can find the mean square speed. So after you get your mean square speed, after from here you get the mean square speed. So you find the root mean square speed. Whatever answer you got here, x, you square root it. That's your root mean square speed. That's the answer. What is the unit for root mean square speed? Of course, meter per second. What is the unit for mean square speed? Meter squared as -2. Okay, be careful. Okay. So the one we are going through is the idea. So let's move on. Next. How do you find this? calculate the temperature of the gas for the atom to have an RMS speed. To have an RMS speed that is twice that calculated in one. Okay. So how do you do this? Someone, okay, let's redo this question. Someone, can you help me to get the RMS speed above? We need this information.
500.
500. 500, eh? Okay, 500. Okay. So the mean square speed, sorry, the RMS speed, the RMS speed. The RMS is found to be 500 for what temperature? For a temperature of 300 Kelvin. How much? 300 Kelvin. 300 Kelvin. RMS is 500 for 300 Kelvin. Okay. Calculate the temperature. Calculate the temperature when the RMS become how much? 1000. 1000, because RMS speed that is twice 1000. So 500 meter per second, temperature is 300 Kelvin. 1000 meter per second, how many Kelvin? That's the question. Okay. How do you do this? The RMS double, is it temperature double? Do you have any formula link RMS with temperature? No, we don't have one, right? The formula linked to temperature is the mean square speed only. We know half mc squared is equals to 3/2 kT. So we know mean square speed proportional to temperature. So the one linked with temperature is your mean square speed, not root mean square speed. So what do you have to do? Although it's 500, 500 cannot link to temperature. How do you link to temperature? The mean square speed. That means what? The 500 square is proportional to 300 Kelvin. Then the 1000 squared proportional to what temperature? This is the proportional you have to come out. You must go back to mean square speed. Only mean square speed linked to the temperature. So can you find the temperature now? So the T going to be what? It's ratio, right? So you can put like this lah. You can say what else? 500 squared over 300 Kelvin should be equals to 1000 squared over T. So you work out your T lah from here. T is 1000. I do here. Sorry. T equals to 1000 squared over 500 squared times 300. Ratio. So you get your Kelvin. Okay. So whenever they give RMS speed and they link to temperature, you can't link RMS directly to temperature. You must change to mean square speed. Just RMS, you square it. And from here you get the temperature. Okay, any questions? Okay, so I really want to highlight this now. The mean square speed linked to temperature. Okay, Playmaker is the mean square speed. But in exam, purposely they give RMS speed. So you change to mean square speed. Okay. Okay, any questions? No questions, eh? So let's go to the last one today. Eh? Okay, so next. State what is meant by ideal gas. What is an ideal gas? Anyone? Shinho? What is ideal gas? Yeah, Shino, can you explain to me what is meant by ideal gas? Shinho?
Gas whose molecule occupy negligible space.
Gas that negligible space. Better answer. It's a type of ideal gas. It's a gas that obeys
All
gas
gas laws at any pressure,
Pressure.
volume, and temperature.
and temperature. Yeah, that's the ideal gas. Huh? So what is ideal gas? It's a type of gas that obeys gas laws at any pressure, volume, and temperature. That's your ideal gas. Okay. So if you say intermolecular force neglected, yeah, its collisions are elastic. That's the property of ideal gas, or kinetic theory gas, not accepted. So what is meant by ideal gas? A type of gas that obeys gas laws at any pressure, volume, and temperature. Okay, next. So state the meaning of the symbol c squared. So it's a mean square speed of a particle. Mean square speed of a particle. Okay. Next. It is that the mean kinetic energy of the molecule of ideal gas is given by the expression 302 kT. So how do you deduce this? From these two formulas, they ask you to deduce this. So reduce that the mean kinetic energy of the molecular gas is by expression is this. So what do you do? The first formula can written as 1/3 mv c squared. You convert it the first formula to this, and the other one is what? PV equals to nkt. So first two equations. Then what do you do? PV is there, so 1/3 nmc squared is equals to nkt, and both sides you times with what? What number? Anyone? You want to find kinetic energy. So 1/3 we want to get half. What times 1/3 you get half?
3/2.
So you times with 3/2 both sides, times with 3/2 both sides. Then you end up getting the equation. So half mc squared is equals to 3/2 kT. So it's a flow. So this is the derivation you have to remember. You need to know how to derive this. It's in your syllabus. Okay. Okay, then last part. Okay, 2 minutes for you. Get a question. So what's the formula to be used? What's the temperature of the atmosphere so that the helium can escape? In order for an atom to escape completely from the Earth gravity, it must have a speed of this speed given. Estimate the temperature at the top of the atmosphere such that the helium, assumed to be an ideal gas, could escape from the Earth. The mass of the helium is this much. So what formula? Half m c squared should be equals to 3/2 kT, right? So half m mass of the helium gas, 6.6 times 10 power negative 27. This is like this is how to get mean square speed is what? The speed given here, you square it, 1.1 times 10 power of 4, square it, is equals to 3/2 kT. Yeah. So find your temperature. Okay, the kinetic energy of the particle should be equals to 3/2 kT. So you can find the temperature at that surface. Okay. So you got idea, eh? Okay, next, last part. What's the answer? Suggest why some helium atom will escape at the temperature below the calculated in one. At the top of the Earth gravitational field, it must have the speed. Yeah. Atom escape completely from the Earth gravitational field. It must have the same speed. They have the speed approximately 1.1 times 10 to the power of 4 at the top of the Earth atmosphere. So temperature is this. Suggest why some helium atom will escape at the temperature below that calculated in one. Anybody?
They have speed faster than the mean square speed.
Yeah, they have the speed more than 1.1 times 10 to the power of 4 because the speed above is actually the mean square speed. Okay, because in one particular temperature, the particle will attain a range of speed. They will have a range of speed. Okay, so there is some particle more than that speed because the value given here, this value is like the mean square speed. It's a mean average. So some particle will have more than that speed, so they would escape. Okay, so you have to say at one particular temperature, the particle has a range of speed. So therefore, some particle will be more than that 1.1 10 for 4. The effect could escape from the surface. Okay, because scientists found that at one particular temperature, this is the speed. The speed will be in a range. It will be in a range. Okay, these all are the number of particles in range. So this value like the mean square speed, mean square speed. Okay, so some particle will have a greater than the mean square speed, which definitely can escape. Okay, class. So this is the questions. You just go ahead, do more questions, try to strengthen it. We're done with this topic. Okay. So yesterday I asked you to submit the question answer. I think only 4 of you submitted to me. Another 3, those who are not submitted, please submit it. Please do so by today. By today, before maybe before 6, I need the paper because you need to contribute. Those who haven't submitted. Okay. So any questions, guys, so far? So on Friday, we will be starting with another topic. Okay, we'll be starting with thermodynamic, the last part of gas about heat energy. Okay. Any questions? No questions, Okay, good. I see you on Friday then.